Hi, I'm going to show you a couple of examples of how to use some of the formulas that you're going to see in your Newton assignment. And we're going to have to use these in a future assignment regarding definite integrals. So you'll see these properties. It says properties of sigma notation. You'll see this in Newton. And this should actually say properties of finite sums because they're just using sigma notation to express some basic properties of arithmetic that we're all very familiar with. So I'm just going to kind of illustrate what these properties are saying. So the first one, for example, it says the sum as I goes from 1 to n of c is equal to n times c. Well, in this one, c is a constant. It clearly does not depend on I. So each term just has a c in it. So I'm going to write this out and explain why this is just multiplication. This is just the operation of multiplication. So I'm going to write it out. So the sum as I goes from 1 to n of c just means c plus c plus c up to c. So each term has a c in it, and there's exactly n of those terms. So when you add up the number c n times, you're just multiplying c by n. So that's just multiplication. The second one was mentioned in class the other day. The second one is the distributive property, and I'll show you why. So the left-hand side says the sum as I goes from 1 to n of c times ai. Well, what does that mean? Notice that every term has a c in it, but every term is multiplied by a number ai, so that number does depend on I, so that number will be different in every term. So if I write it out, it's c times a1 plus c times a2 plus c times a3, etc., up to c times an. And so we have n terms. Each one of them has a c, so let me pull the c out. So I'm left with a1 plus a2 plus a3 up to an. And using the distributive property, or I just used the distributive property, and now I can just write that sum in sigma notation. So this is c times the sum from 1 to n of a sub I. So that's what that second property says. And the other properties, I'm not going to verify them, but you can go ahead and verify them yourselves. And you'll be using all of them in your homework. So let's do an example similar to your homework. So in this example, I'm going to find the sum as I goes from 1 to 21 of 2 times ai minus 3 times bi. If I know in advance that the sum from 1 to 21 of ai is equal to 18, and I know that the sum from 1 to 21 of bi is 5. All right, so let's look at the sum that we're interested in. We're trying to find the sum as I goes from 1 to 21 of 2ai minus 3bi. So we're going to kind of rearrange this a little bit using some properties so that we can use those two numbers, 18 and 5, to get our answer. So notice that we have a sum of a bunch of differences, 2ai minus 3bi. So each term has a difference in it. So there's a property that says we can split that up into the difference of two different sums. So it's the sum from 1 to 21 of 2ai minus the sum from 1 to 21 of 3bi. So that was property 4. And so now we can use the distributive property on the two different sums that we've got written down. So the first one, we can pull a 2 out of each term. So we've got 2 times the sum from 1 to 21 of AI. The second one, I can pull out a 3. So it's 3 times the sum from 1 to 21 of BI. That was the distributive property, or property 2. And so now I'm ready to just plug in the numbers that I was given. So the first one will be 2 times 18. The second one is 3 times 5. And if I did it correctly, I got 21. All right, so in addition to those basic properties of finite sums, we have a major theorem. So in the Newton, it says note sums and powers of integers. This is a major theorem, and it should actually say, I don't know if this is a typo, but it should actually say sums of powers of integers. If you look at the 3 formulas, there's 3 formulas in this theorem. The first one says I goes from 1 to n, and we're taking the sum of, as I goes from 1 to n, of I, which is I to the 1, to the power 1. So there should be a 1 there. It doesn't have to be a 1 there. And then the second one is the sum as I goes from 1 to n of I to the 2. And the third one is the sum as I goes from 1 to n of I to the 3. So these are sums of powers of the integers I as I goes from 1 to n. So the first one, this one is actually famous. It was proven by someone named Carl Friedrich Gauss when he was actually 10 years old. So the story goes that he was 10 years old, he was acting up in school, he got in trouble, and the teacher was just trying to keep him busy. And as punishment, she told him to go add up the numbers from 1 to 100. And he did it in about 3 seconds because he had already come up with this formula at the age of 10. So I'll show you in a different video how he proved his formula. It's pretty clever. But right now, let's just see what it means and how to use it. So if we want to use Gauss's formula to add up, let's say we want to add up the numbers from 1 to 100. So 1 plus 2 plus 3 plus 4, all the way up to 100. To use this formula, we need to write it in sigma notation. So we're actually adding up the integers I from 1 to 100. Right? So it's the sum as I goes from 1 to 100 of I. And using this formula, it's going to be 100 times 100 plus 1, all divided by 2. N times n plus 1 divided by 2. And it turns out to be 5,050. All right. That's what Gauss looked like later in life. That's not 10-year-old Gauss, that's old Gauss. All right, let's do another example using a couple different properties and theorems. So let's find 3 squared plus 4 squared plus 5 squared plus all the way up to 21 squared. So we're starting with 3 and we're going up to 21. And we're squaring each term and then adding them together. So let's write it in sigma notation first so we can use formulas. So this is going to be, notice that I'm starting at 3, not at 1. So this is the sum as I goes from 3 to 21 of I squared. Now, we'd like to use the second formula, the sum as I goes from 1 to n of I squared, which is n times n plus 1 times 2n plus 1 all over 6. We'd like to use that formula, but notice that in the formula, I starts at 1, and in our sum, I is starting at 3. So we have to make some adjustments first. So using one of the original properties on the first slide, I don't remember which property it was, we can rewrite this as the sum from 1 to 21 of I squared minus the sum from 1 to 2 of I squared. So notice that all we're doing is we're taking away the first two terms in that big sum from 1 to 21 of I squared. We have to remove the first two terms. So we're doing that with sigma notation. And so now we can rewrite both of those sums using a formula. So the formula that's here in red says the first sum from 1 to 21 of I squared is going to be 21 times 21 plus 1 times 2 times 21 plus 1 all over 6. And then we're going to subtract off the other sum, which is going to be 2 times 2 plus 1 times 2 times 2 plus 1 all over 6. So we're using that red formula twice. And the first one is 21 times 22 times 43 over 6. The second one is 2 times 3 times 5 over 6. And as long as I didn't make any arithmetic mistakes, I got 3,306. So I used a property from the first list of properties of finite sums, and then I used the theorem, the second part of that major theorem. All right, so this should help you on the assignment that you have that's not graded, plus it should help you on assignments that we're going to have where we have to use these formulas. All right, have a great day.